Okay, good morning, everybody. Let's do, okay. So, all right, let's do some things here, some administrative tasks. I'm glad you guys are here this morning. I'm going to ask everybody to make sure you guys go over and double check your points, that everything's what it should be. Because what will happen at the end of the semester, since we're going into sort of the bottom end there, we're getting close to conclusion. People kind of they kind of don't know much, meaning they don't know what their points are, but it's in Canvas, and you could double check things there. So make sure you double check your points. Make sure you double check things are supposed to be what they should be, and we clarify any concerns or issues, because once we close the books, we move on. And then people are going to come back and say, hey, oh, I never turned in my homework, and I turned it in the wrong place, and I can't scan, and I can't do this, and I can't do that. And if it's not there, it's not there. And we all move on. And we're not going to reopen everything once we've moved on. So, you do have to make sure you get things uploaded to the appropriate places and make sure your points are okay. You have to double check. This isn't, fourth grade, right? It's over when it's over. So remember, you guys, double check your work, double check that your points are what they should be. It's in Canvas, and that's how this all works. So anyway, it's all there. So make sure you guys do your part, because once the semester's over, it's over. And we don't go back, So, okay. So, all right, we got all that stuff out of the way. I had to talk to the calculus class as well. So we make sure students just double check things at this point. And hopefully you guys do. Now, we're going to estimate here sample size today. So some of you guys may notice in your book some questions, and they're asking you to estimate sample size. So I'm going to go to the iPad here, and let's get the TI out too, since we'll be using it. But okay, there we go. And here it is. So you're here, and you're going to estimate sample size. And so let's recall here. Let's write this stuff down. I want you guys to recall that when you were working at first estimating a mean, we had the format: sample mean minus the error, less than the true mean, less than the sample mean plus your error. And then the error was z alpha over 2 s over the square root of n. And here is your error formula. So here's what we're going to work with today. It's right in here. And so when they say to you, because often you might think, listen, before I go out and take a sample, right? I don't want to take out a sample that's maybe a sample size of 500 data values when only 280 will work. Meaning you have to know, first of all, ahead of time, what kind of margin of error is acceptable. And so what people do is they go, okay, I think I want to have a margin of error that's somewhat acceptable within a certain place value, right? And what I'll then go out and do is determine the sample size I need to be within that error. So I don't have to waste my time, energy, and resources getting extra data values when they're not needed. And so in your homework, in the book, and even on the website, there were some estimate margin of error questions. And that's what we're going to kind of look at. So let's kind of look at that. And so in order to do that, let's go back and let's look at our error formula. So here's error. Z alpha over 2 s over square root of n. Now, I'm going to use some algebra. I'm going to solve for n. So when I use my algebra to solve for n, here's what's going to happen here. We get the error is z alpha over 2 s over square root of n. We're going to divide both sides here by the z alpha over 2 over the z alpha over 2, and you notice my z alpha over 2's cancel. Error over z alpha over 2 is s over square root of n. So now I have a proportion, and with proportions, we can cross multiply, meaning diagonal across. So when I do that, I get the square root of n times my error is s times z alpha over 2. So all I did was cross multiply using algebra. And then I divide both sides by the error. Cross this out, we get the square root of n is s. Let's write it down this way. S z alpha over 2 over the error. Now you guys know what I can do here to get n is square both sides. So n here is going to be s z alpha over 2 over my error raised to the second power here. So this is very, very simple. This actually, again, all I used here was some algebra skills from Math 110, beginning and intermediate algebra. And what I did was I took the error formula and I wrote down the equivalent formula, but just now, and remember, is your sample size, right? So if I know S, if I know E, if I know Z alpha over 2, I can actually use this formula and solve for n, and that's the idea. And so this is what we use to estimate the sample size when we go about estimating the mean. Okay, so that's kind of, this is in that first section of homework. This is estimate sample size, and that's when we're considering the parameter of estimation in our future. We're going to estimate a mean, okay? So that's kind of, this is the formula you guys use. So I want to say that when you do your homework and you go through the worksheet, right? And if we say, okay, what worksheet are we talking about? Well, the worksheets that are on the web. When you go through your homework, what you guys should be doing is hopefully you notice what formulas you're using, right? And you go, oh, I've got to use this formula for this. Yeah. So if I go to just the web work, Statistics Lecture 13 that we're talking about right here, we have some questions about estimating sample size, and I think it starts at question 9. Well, let's double check. Use the margin of error, confidence level, and standard deviation to find the minimum sample size required to estimate an unknown population. Okay. Yeah. So question 9 and 10 on your homework here. All right, you guys okay with that? So I'm looking at their question 9 here. So I'm just going to read it. It's read very simply. They're saying here, if we look at that question, they want a margin of error. So what's going to be given to you is the following. They're going to say, use a margin of error. And let's actually make this up a bit better. Let's go to the iPad here. We can create a scenario. Here's what I want to say. We want to estimate the sample size for a study on the mean number of viewers on a YouTube lecture. Okay, so we want to estimate the sample size of the mean number of viewers for a YouTube lecture. Now, you guys don't know, but I can actually see who's viewing. I actually know. And there's an average number, right? In the beginning, we had like 40. And as time goes on, you get down to then 20, down to 12. So not everybody's viewing. Okay? And then that's why I say to everybody again, like I said in the beginning of the course or in the beginning of this lecture, make sure you double check everything for yourself. Your points are what it should be, because we're coming down to the end and then people are going to be going, what happened here? What happened there? And if you weren't around and awake, we move on, right? So remember, you guys want to actually be up to date, good to go, functional, get things done, because we're moving on. This is a college level course. And so, I can see how many people are even here. And that changes. I can see who leaves. So some people check in and they bail. So just want to let you guys know, this is a good example. We want to estimate the sample size for a study on the mean number of viewers on a YouTube lecture. Not my lecture. Who knows? It could be someone else's. The mean number of viewers. So, yeah, ultimately, we're going to estimate, really, mu. But here's the problem. We want to know ahead of time. We want to know ahead of time what sample size is needed to be within an error. And so that's what we should write down, right? So here's the real question today. Estimate the sample size. And I'm going to say, if we want a margin of error of maybe plus or minus 5 viewers, we have to have the margin of error. We also have to have the following. We want the margin of error of plus or minus 5 viewers. And I'm going to write this down. This is key. With the past standard deviation of, we're going to have a past standard deviation here of maybe 1.6 viewers. Okay. And I'm going to say we will be using the 95% confidence level. Now, let me double check to see here. Okay. All right. Well, whatever. We'll see. This is just making this question up. So what's going to happen here, since we have a formula here, now remember, you guys should be writing down the formulas that you guys use because you're preparing for your test, right? You get z alpha over 2. I guess, how do we write that? Do we put the s first? It doesn't matter. And that's not the error formula. I mean, it is, but we're using the sample size. So we have s z alpha over 2, everything over the error. We're going to square this. This is my sample size. So, okay. This is the formula we use. So I'm going to have to find every one of these values. You say, what do you mean? We have a margin of error. They want the margin of error here to be plus or minus 5. So the error value here is going to be 5. S here, ladies and gentlemen, is the standard deviation. Now, I'm going to talk a little bit about this. They say not just standard deviation of 5, of 1.6 in this case. Okay. This came from the past. Now think about this. Here's what we have to think of. We haven't done a study yet. We're going to do a study on the mean number of viewers for a YouTube lecture. So we haven't gathered data yet. There's no data to gather. We haven't gathered yet. We're just trying to find the sample size needed to start gathering this data. We don't know what it is. So what we're going to do now is we're going to try to, before our study, we're going to try to find, hey, what's the minimum sample size I need before I go out and gather data when I know I want to use the 95% confidence level? Well, since I haven't gathered data, I need a standard deviation. It's in my formula right here. And you say, well, how come they give me one? How come they say that's my S? My S is 1.6. The only way they can do that is if this value is from the past. So that has to be from your past, ladies and gentlemen. So there's like a prior study where the standard deviation is given. That's from your past. And this is where they get it. Okay? So, all right, sample size needed from the past. So I want to be clear about that. That you say, if I'm trying to find the number of data to gather, why is it that they gave me a standard deviation when I haven't even gathered data yet? Well, it's from the past. And okay, and now you say, well, eventually we're going to use the 95% confidence level. So I need a Z alpha over 2 then. And that Z alpha over 2 is associated with the 95%. So it's a Z value because it's Z alpha over 2. And so we have to find what Z values are we going to use here for 95% confidence. So here's 95% confidence. And that means, remember, the complement of 95%, you say this is 100% minus 95% is 5%, and that means this is 2.5%. And this is 2.5%. And so I want to tell everybody here, make sure you know the Z values associated with this picture. This is what we're looking for. And you guys don't want to wait till the night before a final to start reading a table. So we need to know the Z values. And then you say, okay, what are the Z values? How do we go back? Go all the way back. I'm going to try to look back here in my iPad. Go all the way back to, where was it? Estimation here. I think it was here. Here's 99%. Here's 95%. It's 1.96. You guys are right. So we have some people here. We got Annabelle who says it's 1.96. And we have Cassandra says it's 1.96. All right. These are the values. Now, so we're going to use 1.96. So let's go back. Where are you? That's the latest one. This is going to go right in here. So like I've always said to you guys, make sure you write this stuff down, right? 1.6 times 1.96. Raise that over 5. That's to the second power. I just plugged in my values. And so what's going to happen now here is I'm going to have to square this. And this is going to be, this is just an experimental kind of question. So let's go to the TI. And you say, okay, TI, let's do our work here. Let's compute this. This is going to be parentheses 1.6 times 1.96 divided by 5. Close that and raise this to the second power. There we go. Let's try this again. Bad example. 1.6 times, close this, 1.6 times 2.96, okay, divided by, let's see what we get, close this here, 5, now square that, what do we get? Oh, that's weird, how come I had, try that again. 1.6 times 1.96 divided by this 5. We close this, raise to the second power. Okay, well, that's kind of a bad example, so I'm going to change some things on you guys. I'm going to change this margin of error for you guys here. So I apologize. Let's change this so it makes some sense. You said, oh, I don't even have to ask anybody. Well, yeah, probably because that margin of error is so big, we want it smaller. So I'm going to say, let's change the margin of error on this question. We're going to go to margin of error plus or minus maybe 2. We could do 1. Plus or minus 1 person. So do plus or minus 1, and we'll raise our standard deviation here. So standard deviation here, we're going to do maybe 3.5. So I'm going to change this on you guys so it makes a lot more sense. Standard deviation. Okay, let's change that. 3.5 margin of error, plus or minus 1. So, all right, let's go back. 3.5. And this will be 1. All right, a lot better. So, 3.5 here. And 1 down here. Okay. A lot better. Let's try this again. So we're going to get now, this is down to what? TID4. Let's go to TI. And we're going to close this here. We're going to get 3.5 times 1.96 divided by 1. Close that and raise this to the second power here. Here we go. And there we go. So you get this number, 47.0596, right? Now remember here, people are going to say, where do I round this answer to? Well, what are we talking about? Let's stop and think. This is data values. So you're going to round to what we call the nearest whole number, or simply the ones position. So, ladies and gentlemen, you're going to approximate this to 47. Or actually, you can say to you guys, you want to do this. We're going to round up to the next whole number. That's actually what you do. You round up to the next whole number. That's the best in this context, because we're talking sample size. You can't get 47.1 data values. You can't get 47.2 or 47.3. You can only get a whole number. So round up to the next whole number. You're going to need to go out and you're going to have to tell yourself, guess what? We have to get 47 data values. 47 data values, ladies and gentlemen, for what we need. And that's how you start this process off. And now you'd go out and take your sample, gather 47, and sometimes the book will write this as saying take n to be at least 47. That's a sample size that's at least that. So this is what we call the minimum sample size needed. And if you get 47 data values and you're working with a 95% confidence level, this is how you start your estimation process. And then you can say, okay, I'm going to go out, randomly select 47 people. I can do 48. I can do 49. I can't do 46. At a minimum, I need 47 people. And that's going to give me an answer within a margin of error of plus or minus 1 people. And that's kind of, you're kind of taking attendance. You're kind of taking roll on this. But yeah, it's very interesting. Like, for example, there's 10 people online right now. And, I think there's still 40 enrolled. So, there's going to be some drama at the end of the semester, and Mr. Judge this, Mr. Judge that. And I'm going to say to people, hey, guess what? Everything was up there. He did his part. And this is college. And it's a learning experience for you. And learn, and that's all I have to say, really. But this is what's going on here. So you guys know there's a sample size. We can actually do this. And we can actually even measure, if I said to you, we can even consider how long are people online on a lecture? What's the length of time? We could do things like that. So we can give another example and say, okay, here's what we want to know. What sample size is needed? Okay. What sample size is needed? For what? Sample size is needed to estimate the mean minutes students watch a video lecture. Okay, now again, we're going to estimate sample size. And they're going to want, we're going to say here, we're going to use the 99% confidence level with a margin of error of, let's say, how about 6 minutes? And I'll put the word past standard deviation. Past standard deviation of, okay, these are in minutes. And we'll say past standard deviation maybe of 20 minutes. Oh, let's do 15. How's that? Okay, so we're going to estimate the sample size. Sample size is, again, what? N. You're going to use the right formula. Who writes the formula down? You do. You're going to use it, so write this formula down for yourself. And there you go. Estimate sample size, right? So what happens now here is we plug in the values. So you say, okay, let's kind of read this and find what things are, right? Well, they're going to want us to use the 99% confidence level. So I have to know that Z alpha over 2 associated with the 99% confidence level. I need that Z value. Anybody happen to know what that is? Right? What's that Z value? I'm going to have to go all the way back to my estimation. 99%? No. There it is, 2.575. Okay, 2.575. All right. So here's the Z value, 2.575. Okay, good. And now we say, well, what is S? The past standard deviation. Anybody know what the past? Standard deviation of what? 15 minutes. There's my S there. So S is 15 here. Okay, the error here. What's my error? They want an error here of, again, what? Margin of error, 6 minutes. So this is going to be 6. Okay. And yes, Joanna has it correct for the Z value. Absolutely. Thank you. All right, now we're going to plug this in, see what we get. Hopefully this is a nice kind of situation. Let's go to the TI. And we do this again, and we say, okay, 15 times 2.575 divided by 6. We're going to close that, and I'm going to raise that to the second power. You get 41.44. Again, since this is data values, you're going to approximate this to the next whole number, right? The next whole number. So stop and think. On a test, here's what I'm getting at, right? This is where you might say, boy, Mr. Judge is really making sure things are good to go at the very end, because this is, you had flexibility from the start and we're tightening that situation down because you need to be functional with this stuff, right? So if you start turning in answers like 41 point and you approximate wherever you like, remember, this is data values. What I'm looking for is that minimum sample size needed. You can't take 41.4, 41.44 sets of data, 41.4414. You have to round up to the next whole number. So this is the minimum size. It's 42. And we write this at times as n has to be at least 42 because, again, this is the minimum that you need, 42 data values. And that's how we actually go about estimating sample size when we're going to estimate a mean. And now you can go out and gather the data. So this is what was on that homework. And if I go to the browser, I know there was some in your book, and I can see 9 and 10 is essentially what we're talking about as well. So you guys know. And then we're going to go to like 11 and 12. That's estimating sample size. And this is going to be for 11 and 12. This will be actually when we estimate, estimate what? For population proportion. So we're going to transition, and I'm going to go back and show you guys, okay, here's now what happens. This is estimating mu. I'm going to say to you, we're now going to estimate P. And that's what we're going to do in the future. But what sample size, right, is needed to start this estimation, right? Okay. So we got some questions here. Do we round to the next whole number? Yes. Cassandra, you always round to the next whole number. Joanna, remember, this is data values, and you can't get 41.44 data values. And what do we have here? We have Sandra. How would I know what to go to and base it off? Well, this is what we're talking about. Have you ever seen a half a data value, right? Have you ever seen 0.2 of a data value? Think of it as a person. Have you seen half a person or 0.2, right? Because every person gives a value. Every person gives a number. So what you're doing here is you're going to round to the nearest, you're going to round up to the nearest whole number is what we're talking about. Let's see, what's the next question? Yes, exactly, Michael. That's correct. And that's why the first problems were kind of weird, or the first example where we had to change it. Yeah. And it's not going to be that way. I mean, it isn't going to be that way. So remember, you're going to round up to the next whole number because you're talking data. N is 10, N is 20, N is 1,000, N is 400, N is 500, N is 100. N is never a decimal. So you're getting the minimum sample size to be within that margin of error, and that's what these questions are based on. And if I look at, for example, question 9 and 10, and 9 and 10 in the answer slot, look at 9. 9 is 90, and 10 is 129. I don't know if you guys can see that here. Right? So 9 and 10 here. 9 is 90, 10 is 129. Those are minimum sample size. It has to be a whole number. All right, so let you guys know. And actually, 11 and 12 are also whole numbers. Those are estimate sample size as well. But I want to remind people here that these videos here, right, these questions that are on the web, I actually have video solutions for all the odds. So there's already a solution for 9 for you on my website. There's a solution for 11 as well. I have those things. So solutions for this worksheet for the odds are there for you. Anyway, let's now transition to estimating that P. So you guys know we're going to estimate P here, but we need the minimum sample size, and that's what they really want to know. The minimum sample size just to start this process. Because remember, time is money. You're going to have to go out and take a sample. You don't want to get 1,000 examples when only 50 will do, or 1,000 sample values when only 50 will do. You don't want to do 200 and only you need 50. We want to estimate the sample size. And so the format that I gave you for this is sample mean minus the error less than P. And that's not sample mean, by the way. That's population mean, or population proportion, if you guys remember that. P hat minus the error. Let's do it over here. Is less than P, which is less than P hat plus my error. And the margin of error again here was Z alpha over 2 square root P 1 minus P over N. So that's your error formula. However, what I'm going to do again here is I'm going to use algebra. I'm going to solve for N. And so I start here with Z alpha over 2 square root P 1 minus P, and that's sample proportion, by the way. So let's change this color again. P 1 minus P. And this is over N. So we're going to solve for N using algebra. So what I'm going to do again now is I'm going to divide both sides by Z alpha over 2. E over Z alpha over 2 is square root of sample proportion 1 minus the sample proportion over the sample size. And again, to get rid of the radical, we square both sides using algebra. And we end up with E over Z alpha over 2 to the second power becomes sample proportion 1 minus the sample proportion over the sample size. Now, I can say cross multiply, but what I'm going to do now instead is we're going to multiply both sides by N. N cancels. And so you get N E Z alpha over 2 squared is a sample proportion 1 minus the sample proportion. And now you're going to divide both sides by E over Z alpha over 2 squared. E over Z alpha over 2 squared. And you're going to get your cancellation again. Here, here. And then you get what's called a complex fraction, which is sample proportion 1 minus the sample proportion divided by the E over Z alpha over 2 squared. And dividing by a fraction is the same as multiplying by the reciprocal. So you'll have Z alpha over 2 over my error squared. Okay. All right, we got another question here. We know we did some algebra. Michael, 5.05 to the nearest whole number is 6 again. We round up, not off. Up, up, up. If I said to you something cost $5.05, well, you can give them $6 and you pay for the item. You're going to the next higher whole number, irregardless. The next higher whole number. Okay, here's my margin of error formula. And I'm going to go to the browser. I'm going to say something to you guys here. If I go back to that browser here, let's take a look at, where is it, browser? Browser. Okay, there you are, browser. I want to show something to you guys, even on the formula sheet, right? The formula sheet and cards I typically gave people here. If you really take a close look at what you have, if you see chapter, it's right in front of you, chapter 6, sample size determination, right? So if you see right in the upper right corner there, chapter 6, that's sample size. This is N, and you got two formulas here. The top formula is what we just talked about. That's when you estimate a mean. This bottom formula I gave you, this is bottom 2 now. The bottom 2 formulas here is what we're going to talk about now. These are the ones that we're using. So, okay, now you might say, I see 2 of them, Mr. Judge. One says proportion, the other says proportion, P and Q are not known. Yes, that's true, not known. So I got 2 versions here. Take a look at that. So this is what I wanted to verify for you guys there online. So here's 2 versions. I'm going to put this in our notes here. Let's go back to what we're talking about, statistics lecture 13. And there we go. So here's the 2 versions here. You say, what's the difference? I'm going to explain it to you. You're going to use this version when past. Remember, this is based on the past right here. Right? This value is known based on past information, maybe a past study. Right? They have that. Past study. Now, you say, well, what happens when it's not known? So I'm going to say, let's note. If this thing is not known, you don't have a past study. There's no past study. Here's what you guys do. You use this to be 0.5. And so you will see a different version there. This is why there's 2. What's the complement? If I use p hat to be 0.5, 1 minus 0.5 is 0.5. So you have, ladies and gentlemen, n going to be 0.25 now. And then I'll put it, this version, z alpha over 2 over my error squared. This is the version, ladies and gentlemen, that's associated that you see online. Oh, Jesus. Doesn't want to draw a. There we go. This is why you see what you see. Because 0.5 here, this becomes 1 minus 0.5 is 0.5. And then 0.5 now times 0.5 right here. This number times this number gives you 0.25. And this is when we say p hat is unknown. So there's 2 versions here. One where p hat is known and one where p hat is not known. And this is why you read online in that formula sheet. And this is why you guys need to actually write that down too. So for example, we're going to have to estimate a proportion. So they're going to start off by saying estimate the sample size needed. And that's a minimum again to estimate a true proportion. Use the 90% confidence level. Okay, you're going to use the 90% confidence level. And the margin of error of, let's take a look at number 11 here. Margin of error, let's use like a small percentage of maybe margin of error of 2%. And you could say plus or minus, but you don't have to. So use margin of error 2% with a standard deviation of, well, let's see, standard deviation, margin error 2%, and that's not, I'm sorry, not a standard deviation. We need a sample proportion, right, from the past. With a past sample proportion of maybe 32%. So you're going to estimate the sample size again. Sample size needed, that's n. Okay, what did they give me? Well, they gave me a 90% confidence level. All right, but let's make sure we first write down the right formula, right? What else did they give me? A margin of error of really plus or minus 2%. Let's put that there in case you guys want to see that, right? And they gave me a past sample proportion of 32%. So since I have past information, the margin of, or the formula for sample size is going to be p hat, 1 minus p hat. Don't forget to put in parentheses, z alpha over 2 over e to the second power. So we're going to use that formula. Now remember, when you guys do your homework, you write this down. This is what you guys are doing as you study now, right? So now go back and say, okay, I need my sample proportion, and you have to know if this past sample proportion is 32%, that as a decimal is 0.32. You got to know those little details, right? So this here is 0.32 and 0.32. That's my sample proportion. They gave that to me. My margin of error, I got to know what that is. You say, okay, what's the error? The error is plus or minus 2%. Well, how do we write that as a decimal? That's 0.02. So this down here is 0.022%. And then we need to know, what is z alpha over 2 with the 90% confidence? Does anybody know what that is? Should we go take a look? 90% confidence, z alpha over 2? No, not 99, not 95. That's 1.645. Okay, 1.645. So we're going to use that value for z. So we got to know that. So remember, I always clarify things, and then I want to talk about this portion here. Because 1 minus 32%, ladies and gentlemen, and no, get this right. Don't make a mistake. I see it happen all the time. Is 68%. That's the complement of 32%. So make sure you get the right percentage. Okay? People make that mistake all the time. So sample size will be 32% times 68. And don't forget, 1.645 over 0.02, and that's raised to the second power. And this is going to be how we estimate the minimum sample size for a study about a population proportion. So this is all just plugging in the right formula and using your TI here. And so, okay, let's go. Where's the TI? Here we go. Here's my TI. And I say, okay, let's clear this out. 0.32 times 0.68 times, put this in parentheses, 1.645 divided by 0.02. Yeah. Close that, raise it to the second power. So double check to make sure you entered everything okay, right? 1.645 divided by that 2% squared. Okay. And we get what? Here's my sample size. So n here is going to be, remember, we round up to the next whole number. Think dollars. Don't tell me 1,472. It's 1,473. Now you say, why, Mr. Judge? Because you're rounding up to the next whole number. Round up to the next whole number. In back of the book, the minimum will be at least 1,473. So you're going to see answers that look either way, like that, because this again is a minimum size needed, and this is how you estimate sample size. So for this sample, you're now going to have to go out and select 1,473 data values. Now you can go up to 1,500, or you could go up to 10,000. Well, let's stop and think about this. The reason you have to estimate is because it's too expensive and time consuming to gather data for a large number. So you're estimating, and this estimate is going to give you a margin of error here of plus or minus 2% if I go out and get this particular sample size. And of course, within the confidence level. So this is how we start to estimate sample size, ladies and gentlemen. This is the deal right here. And here's more to this. This is when we have past information, right? They have past information of a sample proportion, but you don't always have past information. Sometimes it's unknown. And so you can say here, for another example, they may say, okay, we're going to estimate the sample size needed to estimate a sample proportion. I'm going to say now using let's go back to the 99% confidence level with a margin of error. Let's make sure we spell that okay. Of plus or minus 3.5%. You're going to estimate again. Sample size needed. You're estimating N. You got to use the right formula. So you read this and say, okay, they gave me the confidence level. Good. Confidence level. They gave me the margin of error. And then I'm going to sit here and I'm going to say to you, and put it in blue, no past sample proportion is known. So you don't have any past sample proportion information. So you're going to have to use, since we have two formulas, let's go back here in our notes. Double check. This is when P hat is known, the sample proportion. And then this is when P hat is unknown. And you say, what's the difference? Right in here. There's a constant value of 0.25. So you're going to put that value here. In other words, you're going to put 0.25, and then that's multiplied to the Z alpha over 2 value over your error, and you're going to raise this to the second power, ladies and gentlemen. So here's what's going on. So we need to plug things in. I know the margin of error here, they're telling me error is plus or minus 3.5%. We really have to write down the right way of describing 3.5%. So it's going to be 0.035. Okay, you always use in any computation the decimal version of 3.5%. You move that decimal place 2 spaces to the left. You always use that. Remember, we have percent because we talk, we communicate. You know, the idea per 100. Z alpha over 2 is associated with 99% confidence. So I have to go back and say, did we do a 99%? If not, I mean, isn't that kind of good to write on my formula sheet maybe? 99%, what's the Z alpha over 2 value? 95%, what's the Z alpha over 2 value? I don't know. Would that kind of make some sense? Right? Because remember, when do you study for your test? Not the night before. You guys study now. So if it were me, I would be putting that information down. Okay? That's what I'd be putting. So I'm going to go back and say, okay, we need 99% confidence. And let's look for 99%. Let's touch, oh, we got to go back here. 99% confidence. Go to estimation. And 90, 95, 99. Oh, yeah, 2.575. Okay. So that's what I'm going to use, 2.575. So I would hope that's in my, I mean, I'm trying to help myself. I mean, really, I'm going to write this stuff down because I care about what I'm doing. I need to help myself. And yes, Joanna, 2.575. Make sure you have that number handy because it's your test. You guys know? Make sure that information's ready for you. So when you plug this in, and here's what's going on. 0.25, 2.575 out of 0.035. We're raising that to the second power. And I apologize again. This is my N. We got to punch this in. We're estimating N represents sample size. Okay, nobody caught that, not even me. All right. Let's go to the TI and say, okay, TI, this is the last one we did. Let's try this again now. I'm going to take 0.25. I'm going to multiply 2, open parentheses, 2.575 divided by 0.035. Close that, raise that to the second power, and let's see what you get. So N is approximately, remember, sample size values are whole numbers. We're going to round up. You round up to the next whole number. Okay? Round up to the next whole number. Let's go back and do this. Go to the iPad. This is 1,354 data values. So remember, this number is the minimum sample size needed. So now you're free to go out and gather data. Just make sure you don't go out and gather 2,000 data values. Don't gather 100 data values. You need at a minimum 1,354 data values to start this sample process. That's, of course, if you want to be within a margin of error of plus or minus 3.5%. Okay? And this is how you do the estimation of sample size. This is what you guys do. So you're estimating sample size, ladies and gentlemen. Those are questions you're going to see on your test and final. And that actually really concludes our lecture on estimation. So if you go back to the worksheet here, estimation here, right? We're going to say, okay, we're at TI. Where are we? We're going to go to the browser. So this worksheet, Statistics Lecture 13, titled Estimation, I have about 22 questions. Now, remember, here's what I'm saying to you guys. You're going to notice this. You're going to say, boy, Mr. Judge is getting a lot stricter with what he says and does. I go, yeah, because again, we're getting down to the end of the semester, and there are people that still maybe don't even know I have a website. And maybe some people don't know that lectures are online. Maybe some people don't know how to use their calculator. Maybe some people don't know how to use the Z table. Some people may not even know what their points are. Some people don't even know what their points mean. They don't know what percentage is. If you say, Mr. Judge, I'm getting 42%. What does that mean? Well, that means you're getting a fantastic, right? Because this is the standard scale. 90% to 100% is an A. 80 to 89% is a B. 70 to 79% is a C. 60 to 69% is a D. And 59% to 0 is a fantastic. So if you said, I don't know what my grades are, it's in Canvas. That's what those percentages mean. It's the standard scale. So, there's a lot of clarification that needs to be done with people, and they need to understand this, and that you didn't know how to do a lot of details, and even things like uploading. Can you upload appropriately? I mean, if you can't, listen, you're going to have a serious problem because, you don't turn things in whenever you decide. Some people do. I do have calculus students doing that. And it's like, sorry, you missed the window. It's due before class, not a day later, or the night of the due date. So there are people that are still learning how to do some very, very fundamental kinds of things, ladies and gentlemen. Very fundamental. But that's what you do. That's how you learn. You learn by making mistakes. Even if that mistake burns, you learn that way. Okay? And that's the situation you're in now. So make sure, first of all, you know what your points are, what they mean. You're able to upload appropriately homework and this, because those days of, and make sure you do your homework, because people will get this worksheet and just put answers. And say, here you go, Mr. Judge. I got all the answers. They get all the answers right on homework without showing any work, and then they miss it on the test. I mean, those days are gone, ladies and gentlemen. It ain't going to happen here. You're going to see. It's going to burn. All right? It's going to burn good so that you learn and you'll never forget. And that's how you make progress. That's how you do things, is you have to make mistakes and learn and move forward. Estimation. Write down your formulas down that you're using. Okay? I even have videos on the odds. And you say, well, where are those videos? I don't even know. Did you say that, right? This is Statistics Lecture 13. You have a lecture here. You have the worksheet. You got the video solutions here for the odds. And, I'll scroll forward
Alpha
here.
value, level of
There we
significance,
go.
and
Wow, let's look at this.
n
17.
times
Look at
n
that.
minus.
And let me minimize the size here. So for the odds here, I have those as well, but you also have bookwork. Don't skip the bookwork. The bookwork is designed to, and bookwork, actually, I think the book is really good with the questions because you get to learn a lot about statistics. You get to learn the different contexts of what you're doing, and then it makes a lot more sense. Yes, it involves reading, but reading is a learning skill. And I got to say, if you're not reading, you're not learning. It ain't happening. Okay, you got to read. You got to read to learn. It's a very fundamental skill to learning. I still learn by reading. Not everybody spoon feeds you and shows you every detail and feel sorry for you, right? If you make a mistake, that you need to learn. You need to read. So remember, ladies and gentlemen, these are all learning skills. You're going to put it together, and it's a college level course. Every college student in America takes this kind of course as that first step. So remember, you want to read those questions. So people complain about the book questions because it's too much reading. Well, read it, digest it, think about it, because you learn a lot about the material. It's a lot deeper for you, and if it's a lot deeper, you remember. Let's go to the test bank. Just to remind you guys, yes, I have resources here. I put a lot of resources for you. Test bank, you might say test 4. So I go to 127. I'm looking for, 227. And we look for test 4, maybe. Here's the first test 4. Yeah, I think that first set we're going to get rid of because it's always something happened to the link. So here's some terms test 4. That's not your test 4, though. So let's find another one. Let's see, maybe another test 4. Maybe some of the latest test 4s. Okay. Do we see anything here? Okay. Here's something kind of interesting. What is this? Lifespan. Yeah, this is kind of a weird one. Okay. Let's see. Let's look for a test 4. Okay, here's a good test 4. I like this test 4 right here. All right, here's a good test 4. Here's estimation of, show all work for credit. Oh my God, look at that. Show all work for credit. A sample of 150 students revealed 12% leave class early. All right, use a 99% confidence level to determine the margin of error associated with the true proportion. So this first question, the first 2 is about estimating P. The next one's about estimating mu. And it looks like it's a large sample. The next one's estimating mu for a small sample. And you got 5, 6, 7, 8. You're estimating a true mean, small sample. You're estimating the true variance. You're estimating true standard deviation. So here's some good questions for this particular test 4. And you guys, of course, are going to have estimating sample size. So this is a test 4 that has some estimation and it has some hypothesis testing on it. So there is past, and I have the work. I mean, there is past tests. So anyway, this is something there. I got to find some more. So we got here. Here's estimation questions. Here we go. Here's some estimation questions for you guys. Now we get into hypothesis testing. So like the first up to 11, maybe starting from 4 to 11, you have some estimation questions on a test. So, you're going to have to do some digging, but you're going to also have to read and find where it says estimation so that you can understand, oh yeah, this is what they're doing, right? I see an estimation there and I can read this. But this is what's happening at the end of the semester. So you guys know, for these two, for the classes I'm teaching, I got to remind people and all people in these classes, make sure that you guys know how to function even in this environment. You're creating your formula sheet. I will provide the tables for you on the test, and you do your test. It's due when it's due, not when you're done, not when you finally think you're able to upload. So if I were you, practice, whether it's amongst your friends or whoever, scanning your work and sending it, because you have to do this on your test, and it's going to be your test, it's going to be your final, and it's not going to be due whenever you get to it or whenever you decide it should be turned in, because there's an integrity issue here with your exam. Okay, there's accreditation issues. So you got to make sure you guys are good to go. And that's what I'm saying. So you have to organize things. Will I give you a study guide? Of course I'll give you a study guide. But again, if you start asking me questions like, give me the solutions too, and then tell me what formulas to use and when and why, then that means you skipped all the resources. Maybe even the lecture, or maybe you showed up to the lecture. Like right now, there's 10 people here. And maybe we should take roll at the end. I don't know. But to let you guys know, this is we're getting down to the end, and this is where people realize a lot of things. And they realize stuff like, wow, I can't even submit things. Or, whoa, I can't even use my calculator. Or how do I read a table? What do my points mean? You guys know what I'm talking about? So you guys want to get all that stuff together now, because again, even if you're failing, if you pass the final, you pass the class. And I mean pass with a C, not an A, not a B. You get at least 70%. So I'm gearing you up to, hopefully help yourself so that you can pass the course. Otherwise, it's all I can do. That's the best I could do. Anyway, we have a question here. And Cassandra, when is the next exam? So we're in the browser, and let's go to our schedule in the browser here. And 227 schedule. Let's double check. So today looks like it's May 12th, right? So we are in May 12th. I don't know if you guys can see this. Let's try to see if you guys can see this here. Oh, it doesn't scroll. Today's May 12th. We're on week 14. So we have until, if you can see at the bottom, week 17. Week 17, June 1st, you have your next exam. And that's a pretty good threshold for you guys because of the fact that hopefully you can turn things in appropriately that day. Right? Hopefully you guys can do that. Again, it's important. It's important to be functional because it's your test. You have to be more responsible now, not less. And, I ask people to turn things in before class, not later on that day. All right? So it's going to be due. Things are going to be due before class. Make sure you turn it in. Otherwise, I won't accept it. So homework is going to be due before your class starts, not after. So make sure you guys know about that. And if you can't get it in, you can't get it in. Same thing with your exams. When they're due, they're due. You're not going to take them a day later, or after solutions are posted. So this is how it's going to work. You're going to have some problems here. And so June 1st is the next test, and we're at May 12th. And yes, I'll give you a study guide. So that means we're going to start talking tomorrow about hypothesis testing. So we're going to have some hypothesis testing, and that'll be in your exam as well. So anyway, okay, Cassandra, we got your question answered. And we got Sandra. Thank you for all the resources. Well, Cassandra, you're welcome. As you guys remember, there's a former student of mine who was on watching these videos, who was a nursing student. I remember her. Some of you guys may remember her in the lecture last week. Very good student. Studied hard, worked hard for this stuff, and she's doing well. So that's what the resources is for. They're designed to help you. But if you don't use them appropriately or use them at all, they ain't gonna help. They ain't gonna mean anything, because tools are only as good as the people that use them. And if the people don't use the tools, if you say, "Hey, I got a hammer for you. This is how it works," and if you don't use it, it's not gonna be helpful. Here's a screwdriver. This is how you use it. Well, if you don't use it, it ain't going to be helpful. But yeah, make sure you guys get things squared away now. So the 10 people I'm talking about, and maybe the rest will see it later, make sure you get all your things squared away so that you are good to go. And thank you, Cassandra. I try. It's killing me. People don't know my blood sugar has grown. Because of sitting here from 5 a.m. to 5 p.m. putting up resources and doing all this. So my blood sugar is pretty high. So I'm going to be taking care of that stuff. But thank you so much for the compliments, okay? So I wish you guys well. And this all comes from a place that's, remember, I'm a father. And so I have to talk to a class like a father. And I tell you guys things I tell my own daughter. Everything I say to my own family. Which is make sure you do this, make sure you do it right, and this is important. So that's how I treat you guys, as if I treat you as if you were my own children. And yeah, ask my daughter, she knows. She knows, Dad, if she doesn't do it this way, and it's because I wanted to be functional and ready to go. Because it's going to be hard enough dealing with life when you are. It's impossible when you're not. So I wish you guys well. Make sure you start studying your estimation. And tomorrow we'll do hypothesis testing. And yes, I'll give you study guide for test 4 and study guide for your final. And there it is. Okay, so I wish you guys well. Stay safe. Work hard. Keep your head in the game. You got 3 more weeks, I guess, to go. 17 weeks. Or in week 14. And then you're going to really feel like you accomplished something when you're successful. And that's going to be very meaningful for you for a very long time, maybe in the rest of your life. It's going to mean something. You're going to say, I went through this transition. It was difficult. I got there. And wow, look what I learned and look what I did. And if you could do that, then yeah, this is how college works. It's these challenges that you got to meet. So thank you guys both. Thank you, all of you. Thank you, Joanna. Thank all of you for the good work you've been doing. Thank you for being here. It means so much, okay? 10 of you are here right now. So have a great day. If you have issues or questions, see me in office hours. I'll be there. And if you have problems getting in, email me because it's a little tricky sometimes. I have to manage 2 classes and I'm bouncing them back and forth. So anyway, have a great day. Stay safe, and I'll see you guys tomorrow.